present my work that I did during my master dissertation. I'm from Rio de Janeiro, the Federal University, Brazil. We are from the Greco research group, which is a domain engineering in knowledge representation group. And I will pass the. Okay, this is the agenda that we are going to talk about. At first, I will introduce the work stating the motivation, the problem, our objective, and some related works. Then I'll talk about the proposal itself, what we call it OntoWarehousing. Then I will show you the application example. At first, showing how we build a prototype, then how we use that prototype in a real scenario, which is the electric system of Brazil for disturbances analysis, and then I will conclude stating the contributions and future works. Okay, multidimensional design is a very well accepted technique in DaWaK. It's I think everybody already here knows about multidimensional design. And when we're talking about multidimensional design and design itself, modeling itself, we have to look for a characteristic of modeling, the semantic expressiveness. Semantic expressiveness is how we best represent things from real worlds in models. So how we describe this reality in models. So our problem here is how we choose things from the real world and use in the multidimensional model. How we know that a sales is going to be a fact? How we know that a client is going to be a dimension? A product is going to be a dimension? This is a tacit knowledge. So, and the lack of this semantic expressiveness can lead to, can compromise the accuracy of the model and even limit the scope of it. So, how can we express these concepts in EMD schemas? So, our objective here is to formulate a semi-automatic derivation process based in a domain ontology. The use of domain ontology to represent data source is already now in this area, and then we can derive possible multidimensional concepts and multidimensional schemas. And as I said, the use of domain ontologies to represent the data sources is already something already studied, mainly from the professors Alberto Deló and Oscar Romero. You may know them. At first, in AMDO, it's the PhD thesis of Oscar Romero, where he proposed a supply-driven approach, where he looks for the data sources, then he represents these data sources in a domain ontology. Then he looks for the functional dependencies in the domain ontology, and then he states some rules that he can infer, he can derive possible multidimensional concepts. This this supply-driven approach is being evolving. First in GEM, now in OR with their PhD student, and where at first here in GEM it tries to look for information requirements and cross these information requirements with the domain ontology, and then he evolved to OR solution where he considered frequent changes in this multidimensional design. For me, at least, the first time I heard about the use of foundational ontology in multidimensional design was in this paper from Professors Pardillo and Mazon, where they only discuss possibilities of using ontology in multidimensional design. And here they state that they probably can use some kind of interpretation mapping to infer multidimensional concepts, to infer multidimensional schemas. So what is a foundation ontology? A foundation ontology is a top-level ontology, high-level category system which deals with philosophical concerns like endurance, which are the structural aspects of the world, the perdurance, which are the temporal aspects of the world, such as events, situations, the object participations in these events, identity, rigidity, mirror-mimic relations, formal and material relations also. This is a subset of the formal ontology research area. It's an analogous to formal logic area, and it was introduced back there in the beginning of 90s by Professor Nicola Guarino. Professor Nicola Guarino is from Trento University. He founded the laboratory of applied ontologies there, and he's been evolving this theory since then. And he evolved to the Unified Foundation Ontology, UFO. It's nothing about aliens. It's, well, maybe the professors are ETs. They proposed this framework for modeling, and what they did, they looked at these philosophical concerns, they interpreted these philosophical concepts, then they formalized these concepts through first-order logic, okay? And they divided in three parts. The first part is the structural aspects. The second part is the temporal aspects. The third part, which is UFO-C, is the social aspects. And we focus on the temporal aspects because of some similarities to multidimensional choices, such as affect is an event, is a business event, a subject of analysis. And this is the main part of this foundation ontology, where the event can be atomic or complex as well. And a participation, it's a type of an event which inherits participation of two structural objects. And notice here that they axiomatized all these concepts, all these relations. Something that I have to mention also here is that they used also the Allen's operators, where they can compare two events. If one event occurs before another or overlaps another, and so on. And they created a tool, a modeling tool. This is from Nemo Research Group. Nemo Research Group was created by Professor Giancarlo Ghezali, who introduced the UFO Foundation Ontology back there in 2005 in the University of Twente. And they created this modeling tool for validation, verification. They can use OCL for validation, visual validation by verification by alloy analyzer, import and export these kinds of languages. So our proposal followed this Thomas Edison phrase here. We will look at for things that are being applied successfully, such as UFO in a lot of types of domains, since situational awareness to agent-based programs, and also also the multidimensional design for data warehousing, and then we try to enrich the domain ontology with these high-level categories. Then from a mapping rules set, we can look the domain ontology and then derive possible multidimensional concepts and also some ETL constraints to load these multidimensional schemas. So this derivation process suggests these MD concepts such as facts, dimensions, hierarchies, measures, attributes, and so on. So in this paper we described 3 of these rules. The other 2 I used it in my master also. I described it in my master dissertation also. I just defended that last week. And we are going only to talk about these 2 ones. The first one is when we're looking at the domain ontology for events. Events can be derived for facts. When you look to object participations in an event, we can derive possible dimensions or attributes. And when we look for time interval relations, these Allen's operators in a domain ontology, we can derive a snowflake schema pattern. So for each of these rules, we state some graph as example, but also some assertions that if you look, we can describe that as first order logic also, descriptive logic also. And I will not pass each one of these, but I will only exemplify. For example, a sale event is a whole of a payment is a part of a sale, which is an atomic event. A payment has a payment tax event quality, so we can derive a sale event as a fact, then a payment tax as a measure. Okay, if you want to look for the sale, this is the choice of the model, the multidimensional model. If he wants to choose to look for a payment, then he can derive the payment as a fact, the payment tax as a measure here. The object participations as dimension hierarchies also. So a client, it's a participation of something that is structural in the sales event. Therefore, a client can be derived as a dimension. One quality of these clients can be derived as attributes, as an attribute. When you look for the participation, it's a link for the structural part of the foundation ontology, the UFO. Then, looking for all these relations, we can derive possible hierarchies, such as the location hierarchies, which has city, states, and country. It's very common here in data warehouses. The third rule, we look for 2 events and how they relate with each other. Maybe one event occurs before another event. Then each event is derived as a dimension. When we look for the participation of the objects in each event, we can derive possible hierarchies. Also, in this third rule, we could cope with some constraints from Allen's operators to map directly to the where clauses in the SQL. So, looking for each constraint, we can derive directly these where clauses, where we can have each event as a table or a view or some kind of data structure, and then we can relate them by begin and end time points. So in these first three rules, we can summarize as the first: when we look for events in their meteorology, then we can have facts. When we look for the event qualities, we can have measures. When we look for the interval relations between events, we can derive a possible snowflake schema. And when we look for the participations of objects in events, we can derive possible dimensions, attributes, and hierarchies, complementing this snowflake schema. So, to test this approach, we built a prototype where it receives here the domain ontology as an XML file. Something that I must mention, that we use Enterprise Architect with a plugin to a lab tool. And we can export this domain ontology and then use each of these at first to execute the first rule, and then derive possible facts, execute the second rule and derive possible dimensions and hierarchies, execute the third rule, and have some the snowflake schema. Then we have these one events and the other events. We can select each event and look for their relations. An event can occur before another, can overlap with another, and then we have these constraints, and then automatically generates the where clauses for them. So we got this prototype, and we executed in our domain scenario. This is the electric system of Brazil, the national electric system. I'm a software architect in ONS. ONS, the national operator, is the responsible for all the operation in the power grids of Brazil. And we look for disturbance analysis. Disturbance is some occurrence in the network that can cause blackouts, for example, and can be caused by fires or even human failure. And how the news publish about this occurrence? How they talk about the operation of the national electricity in Brazil, and how they can impact how can they impact the ONS corporate image. For that, we have the DaWaK solution, which we call it disturbance BI, to analyze only the disturbance, what are the level, how they affect the network, where they affected, who are the companies involved. Also, we have a clippings website, which is the collection of news publications daily about the electric system. But we don't have a joint analysis between these two systems. The first is a DaWaK solution, the second is not. It's only a web page in the intranet about the publications. Therefore, we have this need to integrate them and use that to experiment our prototype, our approach. Testing our prototype, we could evaluate a domain ontology. We could generate a domain ontology manually, and then I'm showing here just a shortcut, a cutoff of this domain ontology, where we can see here the disturbance event that occurs before a news publication. So what we say that a news publication can talk about this disturbance if that disturbance occurs before it. Okay? Then we see here the participation of equipments such as power transformers, transmission lines, here. And then we executed the prototype to generate the multidimensional schema. affects for the temporal relation between disturbance and miscodification. The event disturbance as a dimension, the terms published in the news as another dimension. Something that I have to mention here, we also use it unstructured data, but it's out of the scope of this paper, but is explained in my master dissertation. Refer that to more detail. Then we designed physically the database in ETL. We constructed and executed the ETL, constructed the data cube, and we used Tableau software to connect this data cube. And then we could do some analysis. For example, the load cut level is a measure from these facts, where it shows if the cut level is too high, then probably there is a blackout. And then we can relate the terms published with this kind of disturbance. Then here we can see that when this disturbance is severe, there are more publications about it. There are others analysis over this, such as press companies that made more publishing about the electricity sector, and so on. So, as a contribution for our work, we introduced this new approach about using foundational ontology in the multidimensional design, which is a subject that was not explored yet, but now this is we could also formalize textually these rules, showing that we can axiomatize them, and we believe that we can increase the productivity of the BI-DW life cycle with this approach. There are several future works, only the top of the iceberg. We think that we have to look all the foundational ontology concepts there, such as object dispositions, actions, agents. Also, we believe that representing hierarchies from material and formal relations, we can also derive hierarchies from that. Also, look for the cardinalities there, can enhance the multidimensional concepts derivation. We have to formalize the rules through axioms, so we can use artificial intelligence tools and reasoning in this ontology. Also, we believe that we can integrate this approach in OLED software and integrate this approach in a more mature tool like GEM and ORI, which are the tools from Professor Oscar Romero. Also, another thing that I didn't put here, we need to exemplify more, experiment more this approach, and I would like to work with other students in this scenario. Thank you very much. Something that I would like to say is that I believe that we can approximate the eye from BI to the eye from the artificial intelligence, because they are different. So by using formal ontology, we can approximate that, and this is the main issue here.